Hello everyone, I'm Xiaoning Chen, comes from the Institute of Data Science. Today I want to talk about my own method on predict the concrete compressive strings. Here are the outlines. First, I will recap the dataset. Then, because last time Professor Lee gave me some suggestion on data modify, so I will talk about my modify on problem solve and method. After that, I will propose exist method and all method on model training and testing. Finally, I will say my expected outcome. The dataset I use comes from UCI Concrete Compressive Strength dataset. The number of observations are 1030. There are 9 attributes. Content of cement, blast ferrous slag, fly ash, water, superplastical, coarse aggregate, fine aggregate, age, 8 input variables, and concrete compressive strength, 1 output variables. By the way, all of the variables are quantitative and there's no missing value on it. And here are the description of variable names. The blast ferrous slag is mixture of metal oxide and silicon dioxide. And the fly ash is coal combustion product that is composed of the particulates that are driven out of coal-fired boilers together with the flue gases. And the superplastic curve is used in making high-strength concrete. And the coarse aggregate and fine aggregate means if the aggregate size is more than 4.75 mm, we call coarse aggregate. Otherwise, we call fine aggregate. And the output variable is concrete compressive strength. Here, I want to solve some problem in some variables like blast, ferrous slag, fly ash, and age. These 3 variables are in balance. It is sure that all of the values are reasonable, but some of people consider that they are outlier. To compromise it, some variables has few extreme values, all well outside the expected range, and these values may have an outsized influence on the trained model. To mitigate the bias in the model, I transform the data to a uniform distribution by using the quantile method. I use data binding method to separate the imbalanced data into 5 classes. Besides, I divide the output variable, that is concrete compressive strength, CCSTR. I divided this into 5 classes. In other words, I transfer the models from regression to multi-class classification. Here is my method. After data binding on some attribute in categorized input variables, I will try different methods on categorical value handling, like one-hot encoding, label encoding, and target encoding. Then, to balancing out effects of lurking variables, I train and test the dataset by four-fold cross validation with stratified sampling for classes. As for method, I won't use the typical machine learning method first. Then I will try to use other methods, such as deep learning method. First, I will use the typical machine learning classifier, like KNN, attribute like GBN, CABUS, or tree-based models to train and test the modified dataset. Next, I want to use deep learning method, which was called DNN, to classify the result. DNN is a method of representing concepts and features using multiple layers of abstraction. The hidden layer is the secret of DNN, which simulates the transmission mechanism of human neurons. The transfer processes in DNN are weighted summation, non-linearly enable bias shift, and conduct to next layer. It's precisely because the nonlinear transformation of the hidden layer is very flexible and it can fit many functions. The rest of the slide is my expected outcome. First, I hope that the accuracy can more than 80%, then the binding can help me improve the performance. Last but not least, I hope that the method I create can be the typical machine learning method. This is the end of my presentation. Thank you.